Okay, the following is a video on how we get the graph of a derivative function given an ordinary function. So the first thing I'm going to do is I'm going to get a square grid. This is my xy coordinate plane. And then I'm going to plot my function, and I'm just going to plot y equals x squared, or f of x is equal to x squared. And if I plot that function, I'm going to zoom in on this function and create a tangent line, or as close to a tangent line as I can. I'm going to come in here and select a line. So if I create a point here, and then create another point that's really, really close to that, it's about as close to the tangent line as we're going to get. But let's zoom out here. And it looks pretty close to a tangent line. Now what I can do is I can actually measure, take this point here, and I can measure the x value of point A. I can also measure the slope of this line. And if I were to animate this line, if I were to like move this line around the function, then I can go to display and I can, I just want to animate the line. So let me just click on the line, animate the line. And as the line moves, the x value changes, but also notice that the slope changes. Now as x gets bigger, the slope gets more and more steep. Now if I have it go the other way, the slope gets less and less steep. And as x approaches 0, the slope of the tangent line will also be 0. And then as it approaches that minimum value, you can see that the slope changed from positive to 0 to negative, and now we have a negative slope. So what I want to do is I actually want to take this x value and the slope of the tangent line, and I want to measure and plot a point. Okay, now if I take this point here, this point is the same x value as the x value of our tangent line, and then the y value is given to me by the slope. So if I take that value and if I measure the x value here, notice that we have the same x value for C as I do for point A. Then if I take point C and I measure the y value, then notice that the y value of that point C is the same thing as the slope of the tangent line. Okay, this is really what gives us our derivative. So if I come here and if I animate my line again, then we notice that as the slope of the tangent line changes, so does the value of C. Now C is just this point that is determined by the x value of A and the slope of the tangent line. So let's go back. Let's bring this back to the bottom. Let me speed it up so we can get moving along. Now what I'm going to do is I'm actually going to trace this point C. Okay, and if I trace that point, I'm going to trace point C, but I'm also going to animate this line and make this line, make my tangent line go around the curve. And as it goes around that curve, if I trace that point, what we notice is that we get another function. We actually get a function by tracing point C. And so what ends up happening is that actually is the derivative function. And so if I were to come in here and I were to actually take the derivative of f, and we know that the derivative of x squared is just simply going to be 2x. If I were to graph another function here and call it 2x, I actually get that line right here, and it fits on top of the line that was traced by point C. So what I want you to gather from this is that as I move my tangent line around, the x value on the tangent line and the slope of the tangent line, if I plot that point as another point C, then, and if I trace that point, then that will actually give me the derivative function. So this is a graphical approach to understand how we actually get the derivative. So I hope that this is helpful. I hope that you can see like why we get these derivative functions and what exactly it is that we're trying to do here. And I will post a few more videos.